Hello, everyone. Now let's see how this question can be demystified. Okay, so we have this light question. Now we have a beam of sodium light passes from air into water and then into flint glass, all with parallel surfaces. So the light beam passes from air into water. When it gets to the boundary separating the air and that's air and water, then the light then refract towards the normal. Now, then into flint glass. So which means from water it then passes into what? Into the flint glass, all with parallel surfaces. That is the boundary separating air and water and that which separates water and glass, okay, are parallel. So now if the angle of incidence in the air is 45 degrees, what is the angle of refraction in the glass? So we are given the refractive index in water. This is the refractive index of water, and this is the one for the flint glass, respectively. All right. So now to solve this question, okay. Now first, let's we need to first identify the given values. So remember, we're giving the angle of incidence. The angle of incidence. Let's say angle of incidence is what we designate as theta 1, which is what? 45 degrees. Okay. Now we're also giving the index of refraction in water. Okay, the index of refraction in water to be 1.33. Then also we are giving the index of refraction in the flint glass, which is 1.63. Okay, so now let's see. Okay, let's analyze the figure. Now, what we have here is that a beam of sodium light passes from air. So which means the first material medium is air into water. Then from air, the light passes into water. So let's say we have the first boundary and the light, okay, the light comes from air, okay. This is the normal ray. The normal ray is the incident is the what is the incident ray or with the light ray which is incident normally on the boundary surface. So the light comes, okay, from air, okay, and the incident ray makes an angle what? Angle 45 degrees with the normal ray. This is the normal ray and this is what? 45 degrees, which is the angle the incident ray makes with the normal ray. So this is the incident ray. So when the light passes from air, the first medium is air, okay. Now the second medium is water, okay. Then the light bends, it bends towards the normal. That means the light refracts towards the normal. So in water, so the second medium is water. So we have the refractive index in air. Don't forget that the refractive index of air will be 1.003. Okay. Now, then when the light passes from air into water, it refracts towards the normal. Okay, so which means the angle which the transmitted ray or the refracted ray makes with the normal ray will be what? Theta 2. So let's write that's the what? Angle of refraction, okay, in water, okay? In water is what? Theta 2. Okay? So now when the light in water gets to the boundary separating water and the flint glass, okay, it then again what? Refracts. It then again bends towards the normal. So remember, when light passes from a less dense medium into a denser medium, the light will bend towards the normal. That means it will refract towards the normal. So the refracted ray is this light ray. Okay, so when the light bend towards the normal, then it will now make a third angle, which is what we have as angle theta 3. So let's say now we have angle of refraction, which is the one we are looking for. The angle of refraction now is what? Theta 3. So now when we look at, now remember we have here that all with parallel surfaces. So which means the boundary separating air and water, and that which separates water and glass. Okay, which separates water and glass, okay, are parallel. So the two boundaries are parallel. And it means that the angle which the transmitted ray makes with the normal ray, okay, will be equal to this angle. So it's the same angle. So the transmitted ray now becomes the incident ray, the light in water, okay, then passes into the what? The flint glass. So which means that the light in water, okay, when it gets to the boundary separating water and glass, then it bends towards the normal, okay. So that's why we have the third angle. So in water, we have the refractive index of water to be 1.33, which is a value we are giving here. Then we also have the refractive index of glass to be 1.63. In this case, we're giving it to be 1.63. All right, so to be able to calculate the value of theta 3, so let's work with the first two material media, that is the air-water interface. So for air water interface, okay, for air water interface, now the refractive index according to Snell's law, okay, we know that the ratio of the sine of angle of incidence to the sine of angle of refraction is proportional to the reciprocal of the what? The absolute refractive index of one medium with respect to another medium. So in this case, so we have air and water. So which means this is going to be what? This is going to be water, air, because it's going to be the reciprocal of the what? Absolute refractive index of one medium with respect to the other medium. So it will now become refractive index of water, okay, over the refractive index in air. All right, so this will be equals to the sine of angle of incidence to the sine of angle of refraction, which is second angle. So in this case, the refractive index of water is what? 1.33. So when we have that over what? 1.00, and then that will be equals to sine 45 degrees. Okay, sine 45 degrees over sine theta 2. All right, so now we know that the value of sine 45 degrees, okay, so this will be 1.33, okay, equals to 0.7071, which is sine 45 degrees, then over sine theta 2. Now, to obtain the value of sine theta 2, okay, so let's rearrange this equation so that we can have sine theta 2 to be 0.7071, okay, over what? 1.33. Now, the second angle, to obtain the value of the second angle, that will be the inverse sine of whatever we get from 0.7071 divided by 1.33, and that will be 0.5317. So we have 0.5317. Now let's obtain the value of the inverse sine of 0.5317. So we have the inverse sine of 0.5317. That will be 32.12. So the second angle is 32.12, and that is a refractive index, sorry, the angle of refraction in the second medium. The angle which the light passing from the first medium makes with the normal is what? 45 degrees, and that angle is called angle of incidence. But when the light is now transmitted obliquely through the boundary separating air and water, okay, then it will refract, okay, it will refract towards the normal, and then makes angle alpha 2 with the normal ray. So we have the second angle. So, and I said the angle, because the boundaries are parallel, so this angle will be equals to what? This angle, alternate angle, okay. Now, but in this case, we need to find out what is the value of the third angle. So to find out the value of the third angle, so this time we now have, using Snell's law, using Snell's law, okay? Using Snell's law. So this time we have water glass interface. So we have water glass interface or boundary, okay? We have the water glass boundary or interface. All right, so for the water glass interface, we know that the light this time passes from water into the glass, okay? So which means that the light from water, okay, is incident on the boundary, okay, separating water and glass. So that becomes the incident light, and the angle which the light, okay, makes with the normal, okay, will now become the what? Angle of incidence. Now then, when the light is now transmitted obliquely through the glass, then the light will bend towards the normal because glass is denser than water. So it will now make an angle of what? Theta 3. So that angle will be called the angle of refraction in the glass. So to be able to calculate the angle of refraction in the glass, remember I said the ratio of the sine of angle of incidence to the sine of angle of refraction is always proportional to the reciprocal of the absolute index of refraction of one medium with respect to the other medium. So in this case, we are going to have, so since it is water glass, so it's going to be glass water, okay? Glass water, because reciprocal of the absolute index of refraction is equal to sine of angle of incidence. So the new angle of incidence will now be theta 2 over sine of angle of refraction. Note, theta 2 becomes incident angle in this case when we are considering the water glass boundary. Okay, so then let's plug in the value. So we know that for glass, we are giving this guy, okay, we have 1.63, okay. Then we know that for water, we are giving this other guy here, which is 1.33, and that equals to sine. Don't forget that we calculated the value of theta 2, and that's what? 32.12, okay. Now over what? Sine the third angle. Okay. Now, in this case, to be able to calculate this guy, okay, now, uh, now we know that dividing 1.63, dividing 1.63 by 1.33, we're going to get 1.226. That will be 1.226, which is equals to, okay, so what is the value of sine? Let's get the value for sine 32.12. So sine 32.12 again will be what? 0.5317. 0.5317 over what? Sine the third angle. So to obtain the value of the third angle, so we know that sine theta 3 will be 0.5317 over what? 1.226. That is when we rearrange the equation. So dividing this guy, okay, by this young man here, that is 1.226, okay, that would be 0.4337, okay. So which means this will be 0.4337. So to get the value of the third angle, which is the angle of refraction in the glass, okay, so what we need to do here is we are going to write this third angle to be what? The inverse sine of 0.4337. Now let's get the inverse sine, okay, the inverse sine of 0.4337, and that would be 25.7. So we have the third angle to be 25.7. So we can approximate that to be, that is theta 3, okay. Theta 3 can be approximated to be what? 26 degrees. And that's the value of the angle of refraction in the flint glass. The noblest pleasure is the joy of understanding. Bye bye.